Howdy folks, this is your video on representing and displaying categorical data. So we're going to do a lot of creating graphs and looking at categorical data here, calculating some percentages. So let's go ahead and jump into it. Right? So just as a reminder, categorical data is data that you can take an individual and put them into one category based on their characteristics, right? So with categorical data, let me turn my text box on here. So with categorical data, you can choose how to represent your raw data. Raw data will be represented with either with what's called a frequency table, where you're going to be given the counts, like how many individuals fell within each category, or it'll be represented in what's called a relative frequency table, where you are given percentages. Okay, so the example that you see on the left side of your screen has both, right? So here, the number, oh dear, terrible. I'm over here drawing on top of things. So this one, the number of degrees would be is just a frequency, right? The percentage right here is a relative frequency. Okay, notice that it gives the percentages of each one. In order to figure out what these percentages are, right, they took the number in the category divided by the total number of observations. Okay, so here, for example, for engineering, to figure out what this percentage was right here, they did 72,654 divided by the total down here. Okay, this is what you've been doing in math since basically elementary school, right? We're just doing part divided by whole in order to get the percentage. Okay, all right, so let me erase this here. Okay, like I said in the last video, whoops, clear that off. Okay, like I said in the last video on basics, that there are two ways other than tables that we visually display categorical data, right? Finished data, we either will show with a bar graph or a pie chart, okay? So you only want to use a pie chart when you are comparing each category to the whole, okay? So what that means is that you really can only have you have one variable, right? And you are looking at the data, and you're saying this category had 45% of the observations, then this next category had 20% of the observations, this category had 10, etc. Right? Okay. You'll use bar graphs for basically everything else. Okay. Mostly because, and I know this isn't written on the left side of the screen, but mostly you'll use bar charts more than pie charts for the most part, because they are more flexible and they're more precise than pie charts. You can get a lot more information typically out of a bar graph than you can a pie chart. Now, one thing I want you to notice over here that's very important for a bar graph in particular is that there is space between the observations. Okay, between each category there is space. Okay, the reason that that is important is because you will also see histograms, right, that look something like this, right, that may look like this. Okay, this is a histogram. Notice that there's no space. Ooh, no space. Okay, other than that, histograms and bar charts look very, very similar to each other. So the way that we differentiate between them is that histograms have no space in between the bars, or they're called bins in a histogram. And there are spaces in a bar chart between the bars. Okay, histograms are only used for quantitative data, and bar charts are only used for categorical data. Okay. All right, so let me clear this off. Right. Most of the time, you will see data represented in bar charts. It's more common than pie charts on the AP test. All right. So a key thing to look at, especially with categorical data, it shows up sometimes in quantitative data, but people especially like to present you with misleading graphs when you're dealing with categorical data, especially. Okay, so there's a couple of rules, okay, and common mistakes that people make when including or when creating a bar graph that you want to make sure that you avoid. Right. So first rule is that bar graphs should have bars with equal width. Okay. The reason for that is because our eyes react to area. So if you look at the first example on the left side of the screen here, you have these people, right? This guy in the Netherlands is much wider than this guy in the Philippines, right? So our eyes play tricks on us and make us think that the difference in height is much larger for this guy in the Netherlands with this guy in the Philippines. But if you actually look at the at the numbers, like what the actual height is in those countries, for the Netherlands, it's about, I would say, 1.84 meters, and for the guy in the Philippines, oh, I'm having to draw my line across here. I would say it's like 1.62 maybe meters. So the actual difference between those is not very much. It's about it's like 0.2 approximately meters, which really is not very much, like a fifth of a meter. But because of the way that this graph is made, it makes us think that the difference between the smaller guy and the really big guy is much larger than it actually is. Okay, so when you're creating bar graphs, you want to make sure that they have equal width because our eyes react to area. Okay, another thing that's really, really important to watch out for is misleading axes. Okay, if you look at the second one over here, Fox News likes to do graphs like this a lot. I'm not going to get into it any more than that, but this is a very common thing that shows up on Fox News. And other news networks as well, but I've seen more examples from Fox News than any other news network. So here, if you look at this, it looks like the tax cuts that were made, or what the tax rate is, would drastically, it looks like with the way that this data is represented, it looks like it would quadruple, right? You would do like ×4 of whatever this was in order to get this. But if you look at the axes starts at 34%, right? And see how they make the actual numbers here really, really small. So the actual percentage in this huge bar is 39.6%. And the one here in this bar is 35%. So the actual percentage is, like, the difference in percentage is less than 5%. Okay, but that is not represented by this graph. Okay, so be careful about misleading axes. You always want to start, especially when you're dealing with percentages on the side, that you start with 0, right? And then work your way up from there. Okay, and then the very last thing, it's very important when you're doing any graph, but in bar graphs especially, make sure that you include labels, meaning label your axes, right? Like, what does your x-axis represent? What does your y-axis represent? And what each bar represents, so what category it is. Okay, so you have to include labels. Make sure you include scales, right? Meaning like the y-axis scale, like the percentages versus counts. Okay, and a key. Okay. So it's important to include a key. If you like if your graph is not clear, like if your graph is not clearly labeled. All right. So let's take a look. Let me clear my screen off on the left side. And let's take a look at an example here. Okay, so here's our example, and here's our information. Okay, so they say here these are percentages of 12 to 17-year-olds who post these different types of information on their social media profiles. So we're being asked to display the data in a bar graph, label, right? Make sure you do the labels and the axes. And then they asked, is it appropriate to make a pie chart for these data? So I went ahead and drew these on paper, drew the bar graph on paper. So give me a second to insert that picture, and then we can talk about it. But if you would like to try this on your own, what I would do is pause the video, draw the bar graph on your own, and then check back and see if yours looks like mine. So I'll see you in just a second. All right, folks, so take a look at the right side of the screen and you can see my bar graph. Okay, so we had 5 different categories here, 1, 2, 3, 4, 5, and all of them had a percentage. So I made sure that I included a couple of things, right? I included labels for each category, right? So photo, school, town, email, and cell number, right? I just took, you don't have to write the whole like category name on your graph as long as you're clear about which is which. Okay, I also included labels on the axes, X and Y axes, right? That this is the type of information down here on the X, and it's the percentage that post on the y-axis. I made sure that I started my my graph at 0% down here, and it went all the way up to 100% because I had a number that was fairly large. I had a 91%. That was pretty large. And then the other thing I made sure to do was I made and included a space between each category. This one doesn't really need a key because I'm only dealing with one variable. I'm only representing one variable. I'll show you one in a second when we get down to a conditional distribution where a key is necessary. All right, so let me zoom out so that I can type this a little better. Okay, so then the second question is it appropriate to make a pie chart for these data? Right, and I'm hoping that your gut instinct is no. So the answer is no, okay? And here's why. If you look at the actual data, right, these all of these categories are separate, right? We can't combine them into a whole. We didn't ask how many of them just post information where they could answer with a yes or no. That you could represent as parts of a single whole, but these we can't do that. These are not parts of a single whole. And also, if you look at them, if you're thinking about doing a pie chart, all of the percentages together have to add up to 100, and this adds up to way more than 100. So the answer to this question is no, okay? And your explanation does not have to be long. Just a sentence like this is fine. So each percentage in the table refers to a different type of information. Okay, not to parts of a single whole. Okay. Right, so each percentage refers to a different type of information, not to parts of a single whole. All right. Okay, so give me 1 second to get to the next part on my slides here. We're going to talk about two-way tables and distributions in the next part of the video. So I will see you in just a moment. All right, folks, so let's talk about two-way tables and the different distributions that you can gather from two-way tables. So in the previous example, and in a lot of the previous examples you've seen, we've been dealing with one-way tables, right? Meaning that there's only one variable, one categorical variable that we are dealing with, okay? In a two-way table, okay, a two-way table describes two categorical variables, right? I know, shocking. So it describes two categorical variables from the same set of individuals. Oops, I'm really over here struggling with my typing today. The same set of individuals in one table. Okay, so I'm showing you everything, right? We're displaying two different variables at once. Okay, so there's always a row variable and a column variable. Okay, so what you see on the left side of your screen is a great example of a two-way table. Okay, so there's two variables that we're dealing with here. Okay, the first variable is gender, and the second variable is opinion. Okay, so you have your row variables, right? What changes by row, which is opinion, and then your column variables, which is this guy, the gender at the top. Okay, and then one thing you want to make sure that you notice is that totals always show up in the bottom row. Okay, so those are the totals for your columns, right? All of these added up equals this number here. All of these added up equals this number here. Okay, so those are your column totals at the bottom, and then the row totals are here on the right. Some two-way tables will not give you the totals. So key point and my best piece of advice is if the totals are not given to you, then you should just really quickly add everything up and figure out what the totals are, and just write it out to the side, like this one is, and underneath for the columns. It will make solving the rest of the problem much easier. Okay. All right, so from a two-way table, there's a couple of distributions that we can create, and then we can represent the data with. Okay, so the first is called a marginal distribution. Okay, so a marginal distribution shows the distribution of only one variable. It's like taking the two-way table that you just saw and converting it almost to a one-way table. Okay, so essentially what you're doing, why it's called a marginal distribution, is because you're working only in the margins, right? So for example, the one that you see on the left side of your screen here is the marginal distribution for opinion. Okay, so all we did is looked in the margins and got the totals for opinion, right? And figured out what the percentages were, right? By doing the total in the category divided by the total of the table, right? So we're literally just working directly in the margins, and then they created a percentage bar graph over here for opinion. So this is the marginal distribution for opinion. Okay, essentially what we're saying is I don't care who, like if they were female or male, that doesn't matter to me. I just want to know how many people or what percentage of people picked this opinion versus this opinion versus this opinion. Okay. If you were to go the other way, right, you could also figure out the marginal distribution for gender, right? And it would be a much simpler distribution, right? You would have female and male, and then you would have a percentage here, right? Your percentages would be here, right? So female would be whatever this value is, 2367 over 4826. And that would give you a percentage. And then for male, you would do the same thing. So it would be a much smaller, so this would be the marginal distribution of gender. Okay, so marginal distributions are pretty simple, right? Because you're taking something that's really expanded and turning it into something that's less expanded and a little bit more simple. Okay, conditional distributions are the ones that are a little bit trickier. Okay, so a conditional distribution takes certain conditions into consideration. Okay, again, shocker. A lot of these things in statistics are named in a way that it makes sense why they're named that way. Okay, so a conditional distribution describes the values of a variable among individuals who have a specific value of another variable, meaning that I'm going to provide you a restriction of some kind. Okay. So in our previous example, right? Let me go back to the actual two-way table here. 1 second. Oop. Sorry, everyone. I'm over here hardcore struggling. I have to get this back so that I can click back. So here, a conditional distribution would essentially make a distribution relative to the others in that particular row or column without taking into consideration the other rows or columns. So here in this one, for example, I could say I want a distribution just of the males, like the opinions of the males, right? So I would create my percentages and my distribution completely ignoring the total column and completely ignoring the female column. I'm saying I'm providing you a restriction. I'm saying I only care about the males. So I'm going to focus in and zoom in just on that category, right? And see what changes there are from opinion just in that male category, right? So that's my restriction. So rather than calculating percentages with this total in the table right here, you calculate percentages using the total in the restrictor category, right? Because I don't care about how many females there were. I'm focusing only on the male category for an example here, okay? So the way that you actually calculate those percentages, rather than doing the total in the category divided by the total in the table, right? You calculate those percentages as the number in both categories, okay, divided by the total in the restrictor category. Okay, and I'll draw a little, kind of center this a little bit. And then this is a fraction. Cool. Okay, right? So in my example here, I was saying we could examine the opinions of only men in a two-way table. So the number in both categories would be the intersection of the two categories. Like I'm concerned about the distribution of opinions just for men, right? So here, and they do this, they kind of break it apart here in this table that you can see, right? Where notice how they're dividing by the total in the category, right? See it down here, the 2367, to get the distribution of opinion for females and the distribution of opinion for males, right? So I provided you a restriction, okay? With conditional distributions, most of the time we represent them in something called a side-by-side bar graph, okay? Because it allows you to see the differences between the two variables in each category, right? So here, if you look at this conditional distribution, right, and even looking at the percentages, you can tell that the opinions are about the same for men and women for the 50-50 chance option, but there's a huge difference in opinion for between the genders for the some chance option. Okay, so we typically use the side-by-side bar graphs. Other times you may see what's called segmented bar graphs, which look something like this. So essentially what they do, if I have female and male, so essentially you have percentages on the side and it goes all the way up to 100%. And essentially you're putting all of the categories in one large bar and then dividing the bar up depending on what percentage of subjects fit in that particular category for opinion here. So here I would say that bottom bar is almost no chance, and then this would be some chance. Then there's 29, which is much larger. So this would be the 50-50 chance. And then I didn't draw this very well, but then you would have this one, which was a good chance, right? And then this would be you're almost certain, right? And then you would do the same thing for the men, right? So you'd be able to compare the size of the segments rather than the heights of the bars. So for men, it would probably look something like this. So this one that said that had some chance was smaller, so some chance. This was about the same, the 50-50 chance. There was a much larger percentage for good chance. And then you have the almost certain. Okay, so that's an example of a segmented bar graph. Okay. Those don't show up very often. You're more likely to see a side-by-side bar graph than you are to see a segmented bar graph like that one. Okay, so let me clear this off. All right, and then one other thing I got to tell you about before I do an example for you, which is there's a very common type of question that shows up for categorical data, which is, can you say that there's an association or a relationship between these two variables? Okay, so if you are asked if there is an association between variables, you have to make a claim, right? Meaning, yes, there is an association, or no, there isn't an association, right? And then you have to support the claim by comparing percentages between the two groups in context, okay? And I gave you a word formula there. So you would say something along the lines of, there is/isn't an association between the two variables. So in our example here with the gender and the opinion, right? If I asked you, is there an association? You would probably say yes, because of the differences between most of the categories, right? You can see there's a difference between male opinions and female opinions in most of the categories that you have, right? So in that word formula, you would say, like here in our example here, there is an association between gender and opinion. And I'm abbreviating, but you would say opinion on blah, 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 blah. Okay. So for example, we would say that females with who feel with the opinion some chance, you would say something like is reported at higher or lower rates than that of then the same thing for male with the opinion some. Okay, and I think it was higher, like a higher rate. Okay, so essentially you're trying to describe the differences that you see within a particular category, and just providing an example, right? So here, right, I didn't write this very well on this screen, but essentially, because it's hard for me to do when I'm not looking at the actual data, but here I would say there's an association because there is an association between gender and opinion. For example, the females who chose the some chance opinion is higher than males who chose some chance. And then you could give other examples and say, and that idea switches when for the good chance opinion, where males are much higher, right? So males are more likely to choose the good chance opinion and the almost certain opinion than females are. Females are more likely to choose the some chance option or the 50-50 chance option. Okay? So you're just trying to describe essentially what you see, like who's more likely to choose what category based on either the percentages that you see or the visual representation of the data. All right. Okay, so give me 1 second to set up this example here, maybe if it's going to cooperate with me. Okay, so we're dealing with, this is a two-way table dealing with some cell phones. Okay, so I asked you to calculate the marginal distributions for cell phone type, and then make a graph, and then we're going to talk about some of these ideas. So give me a second because I'm gonna pre-write some of those things on here, and then I will talk you through them. I apologize about the way that this showed up here. Sometimes when I click the little annotate with Cami button, my formatting gets a little messed up. So I will see you all back here momentarily to talk about all of these ideas. All right, y'all, so let's talk about this one. So the very first part of this question said, use the data to calculate the marginal distribution in percentages for type of cell phone, right? So that means that I don't care what age group they're in, right? This does not matter to me. What I care about is the totals in the cell phone categories. Okay, so all you do is take the total in each category and divide it by the total in the table. So for iPhones, that's 467, Android's 503, other 1054. So you get 23.1%, 24.9%, and 52.1%. I did make a note here that there is a little bit of error just because of rounding. That's fine. Okay. 2 says make a graph to display the marginal distribution, okay? Meaning I just want a graph of these three things, right? So I'm only going to have one variable on here, and there's only 3 categories for that variable. So the variable is the type of phone, and then on the y-axis, what you'll see is the percentage, right? I chose to do percentage rather than frequency, just because I had already calculated the percentage, and it's a little bit less like tick marks for me to make, right? So here you have your iPhone, your Android, and your other, right? And then it just says describe what you see. So what I see is that the percentage of people who own iPhones and Androids are about the same, which is true, right? There's not a large percentage difference between them. And then the other thing that I noticed that sticks out is that more than 50% of cell phone owners own a phone that is not an iPhone or an Android. So they own something else. Okay. So when they say describe what you see, just pick 2 things typically that stick out to you. And that's usually enough. Okay. Number 3 says use the data to calculate the conditional distribution of cell phone type for the 18 to 34-year-olds, okay? So the restriction that I'm putting on you is that I only care about the 18 to 34-year-olds. So that is my restrictor category, okay? So if you go back up to the table, what I'm saying is I now don't care about the total, and I don't care about the 35 to 54-year-olds or the 55 plus. I only care about the 18 to 34-year-olds. That's my restriction, okay, which means the rest of this stuff in the table I don't care about, meaning that I'm not dividing by the total in the table. The total now that I'm dividing by is the total in that category, okay? So you're essentially doing the exact same thing you did for the marginal distribution up here. We're just changing the denominator, right? The numerator obviously changed, but we're going to change the denominator here. So I took the total in both categories, meaning 18 to 34 and iPhone, right? Because they intersect right there. Okay, so the total in both categories divided by the total in the restrictor category, which is 517. So I got these three percentages, 32.7, 41.4 for Android, and 25.9 for other. Okay, and then 4 was the most in-depth one, which is there evidence of a difference in the distribution for the 3 age groups, i.e., is there an association between age and phone type, okay? So what I did is I calculated the conditional distribution for the other 2 age groups, okay, using a similar tactic, right? The exact same steps that I did for number 3, right? And got these percentages, right? And then plotted them on a conditional a side-by-side bar graph using the conditional distributions, okay? So this is the place where a key is necessary, right? Because I have 3 different variables in each age group, or rather not 3 different variables, sorry, 3 different categories of phone within each age group. So I have to make sure that whoever's reading my graph knows which is which. Right? So you can see the differences, right? As we age, the green guy increased, right? The older you get, the more likely you are to have an other phone, okay? And then for iPhones and Androids, the younger you are, right? So you're more likely to have an iPhone or an Android when you are younger. Okay, so I wrote the conclusion very shortly, saying, like in shorthand form, saying that young people prefer iPhones and Androids, and older people show preference for other phones. Okay, so the way you would want to write this, though, if you were actually writing the whole thing, and I'm going to put it underneath. I'm going to put it underneath down here. Sorry, it's a little all over the place here. So you would say something along the lines of, there is an association between age and phone type. For example, those in the 55 plus age group are more likely. Let me see if I can, no, it won't let me do that. Are more likely to have an other phone than those in the 18 to 34 and 35 to 54 age groups. Okay. And then you can also talk about how the younger people are more likely to have an iPhone or an Android than the other phones, right? So that's showing an association between those. All right, y'all, so that is the end of this video. The next one is on displaying quantitative data. So we're going to do a little bit more calculating with averages and doing all that fun stuff in the next one. So I will see you in the next video. Bye, everybody.